Once that goes off. Okay, cool. Welcome, everybody. Thanks for joining us. Depending on what meetup you're in, could possibly be part of the Iowa, Kansas City, um, maybe Omaha even. Hit approve on that. Chicago, or maybe even Denver. So with any of those, feel free to continue to share or follow whatever region's closest to you. I'm Alec Harrison. If you don't know who I am, I try to run those groups on Meetup. We're always looking for local organizers. We try to do in-person events at each of our satellite user groups once or twice a year. So if you want to be involved in running that user group, feel free to reach out to me, either LinkedIn, Teams, any way you want to. And if you are in an area that doesn't have a user group, feel free to reach out too. We're always looking to grow and expand. With that, the presentation today might not take the whole hour, so we're going to reserve the end for an Ask Me Anything if you have any AI specific questions or if you want to dig deeper in the solution as well. So with that, I'm going to hand over to our speaker today for him to introduce.
Thank you, Alec. Let me just go ahead and share my screen. Is this all visible to everybody? Awesome.
Yep, we got you.
Yeah, sweet. Really appreciate everyone's time today. My name is Feynman. I'm the CTO of Blueteam AI. We are a private AI infrastructure company. And the talk today I'll be presenting about is how to deploy your own private AI infrastructure on Azure. In particular, we'll be talking about two notable open source projects, Ollama and OpenWebUI, as well as a standard, I think it's all open source, a standard open source tool chain for deploying, managing, and operating this stack. Feel free to connect with me on LinkedIn. My LinkedIn URL is right there. And if you scan that QR code with your camera, it'll take you to my LinkedIn profile. But with that, let's get started. So I once had a mentor tell me that I should take my best line and bring it up front. So here's my bluff here. The end results of this talk is to build this right here. I have an IP address inside of Azure's CIDR block. And on top of it, I've deployed a Kubernetes cluster, which has this front end here. It's called OpenWebUI. And you can see that the model that we're talking to, in this case, is Llama 3.2, 1 billion, also deployed on the same cluster. And we have interactivity. We have a very basic chat going on. So I'll break down all of the ingredients that together comprise this end product over the duration of this talk. Specifically, it's going to be this little layer cake on the right here. We'll start by talking about open source artificial intelligence, what libraries and what tools and projects are out there. And for the application layer, I'll be choosing OpenWebUI. This provides essentially like a chat-like interface, which is agnostic to the model backend itself. For the AI layer, we'll host our own large language models using Ollama, and we'll run all of this infrastructure on top of Kubernetes and Azure Kubernetes Service, managed declaratively using OpenTofu, which is an open source fork of Terraform. At the very end, I'll give a very brief walkthrough, the exact commands that I run in the terminal in order to deploy this for both this project as well as for customers, which we serve using this template. And then I'll open it up for questions at the end. If you're impatient like me, if you just want to take the code, or if you want to take the code and follow along, feel free to go to this URL or scan this QR code. My slides that I'm presenting here are also available in PDF and HTML format under the slides subdirectory of this project. And with that, let's get started. So let's start with the application layer. We'll work our way from top to bottom in this layer cake. The application layer will be provided using a project called OpenWebUI. I personally really like OpenWebUI. I think it's one of the most polished front ends when it comes to large language model front ends. And its mission statement is to essentially clone all of the features that you see and enjoy inside of ChatGPT and more. Specifically, With Open Web UI, you're not bound to just the OpenAI models. You can add a variety of models. And in this case, I'm showing all of the models that we have configured inside of our Blue Chat product. Of course, the Anthropic models are there. And since we're already running on Azure, it's easy to add an intranet link to the Azure OpenAI service. But you're also able to incorporate other vendors, such as Vertex, or our Llama stack models, or our OLLAMA models, such as this Llama 3.2 instance that we have here. And while like everyone has used ChatGPT and is familiar with direct chat with one model, one feature that we really enjoy using in OpenAI or Open Web UI is the ability to dispatch to multiple models at the same time. We find this is particularly helpful when working with customers and helping them understand which model is best for my use case. How do I trade off between latency versus cost versus response quality? So in this example here, you can see that instead of just having one model, I've picked Azure OpenAI, Anthropic Claude, as well as Llama 3.2 as 3 different models for us to compare the same prompt against. In this case, my example prompt is to explain options trading. And you can see that while Azure OpenAI and Anthropic have generated a detailed response, this Llama 3.2 model, which we're currently running on a CPU, is a little bit slower and hasn't completed generation at the time of the screenshot. We can do more than dispatch to multiple models. We can also equip these models using Open Web UI with tools, such as web search. So in this case, I'm asking it a real-time query about the price of Bitcoin today, November 21st, 2024. And it's gone out and searched 3 different websites in order to retrieve real-time information. The price of Bitcoin today is $97,000. Seems to be mooning. Lastly, I want to talk about this chat with documents use case. Similar to how you can upload documents to many popular consumer chat frontends, Open Web UI also gives you the ability to take a document and click this Upload Files button and upload it. The document is then chunked, embedded into an in-memory vector database, and RAG is used to enable retrieval augmented generation use cases. In this case, I've actually uploaded my slide deck to this chat instance, and I've picked Google Gemini 1.5 Pro as the model that I'd like to utilize. And I've asked it to summarize what this talk is about. And you can see the summary that's given back is open source focus, OLLAMA, Open Web UI, Open Tofu, and Azure. Fairly accurate about what we're about to discuss now and what's coming in the next slides. So we've got our front end figured out. It's Open Web UI. We now got to figure out what are the underlying models that we could, or what's the AI layer? Where are these large language models that we're going to provide? And you can already, and it's very easy to just add an API key and connect with OpenAI to connect with Anthropic. You can saw in our previous examples, we had already shown connections with Vertex AI's Google Gemini instance, as well as Azure's OpenAI instance. But I want to draw attention to another open source project here, OLLAMA. OLLAMA is, oh, sorry, are you not able to see the screen share?
No, I'm wondering if it's a him issue. You might need to leave and rejoin the meeting. I'm seeing it move on my end, and it looks like
It works for me too.
cool.
Awesome. Yeah, I'll continue here. So I'm currently on the open source LLMs with OLLAMA slide, where underneath the application layer, we've layered on the second layer, which is this AI layer provided by OLLAMA. And to take a step back, I want to compare open source large language models versus these proprietary vendor models. Why might you consider using a project such as OLLAMA? The first and most obvious is cost benefits or predictable cost control. These proprietary vendor models are charged on a usage basis where you pay per million or per 100,000 tokens. And as your application grows, your costs will also scale accordingly. And when you have bursty traffic, your costs quickly become unpredictable. In contrast, when you deploy your own large language models on your own infrastructure with OLLAMA or similar projects, you gain predictable cost control. You know exactly how much infrastructure you've provisioned, and that infrastructure costs the same every month, independent of usage. Furthermore, you gain freedom from proprietary vendors. When you use a model vendor like OpenAI or Anthropic, you're renting an API, and that API is not always stable. It may not always be available. The chat or the GPT-3.5 models from 2023 have all entered maintenance phase and will be deprecated soon. So you're forced to follow this regular update cadence, and you don't have reproducibility of your applications. In contrast, with these open source models, you own the model weights, and you're free to spin up instances whenever and wherever you desire, whether that is on-prem, on a virtual private cloud, or inside of your customer's cloud. And lastly, these open source models in the past have had quite a significant performance gap. Open source models were primarily produced by academia, and it's just an unfortunate fact of reality that these researchers are not as well funded as in industry. And so we haven't really seen that many very large open source large language models in the past. But this has quickly been changing. We're starting to see industry participation. For example, Llama, released by Meta, has scaled up to 405 billion parameters, and Grok 2, released by Elon Musk's company xAI, is now currently one of the largest open source large language models to date. And the performance gap is closing. We're noticing that Llama 405 billion is competitive with state-of-the-art releases from top closed source vendors, such as Claude 3 Opus, as well as OpenAI's GPT-4o. There are many open source.
Sorry,
Yeah.
I was going to say we have a question in chat if you're cool with it. Somebody was asking, am I able to deploy an OpenAI Llama model on my home lab environment, or will I have to have some sort of service or resource requirement from a cloud service provider?
That's a good question. You are totally able to deploy this on your home environment. In fact, I actually have it running in my home lab over in the corner over there, and I'll provide you with templates to, I'll provide you with or Kubernetes manifests to apply if you already have a Kubernetes cluster running. You will need to adapt the OpenTofu scripts to utilize your home, whatever software you're running in your home lab as a provider, rather than the Azure providers. Yeah, no problem. Happy to answer questions as they arise. There are many open source models available for us to consume, and it can be a little dizzying navigating the landscape. The most recent models that are, a generation ahead, I would say, would be the llamas being produced by Meta, as well as the Mistral models, which actually are not included on here. But for historical purposes, I wanted to make sure that we were all aware of BERT. BERT is the original bidirectional encoding representations for transformers produced by Google, and it's the backbone of every single large language model we've seen to date, as well as Bloom. Bloom is, what I would say, the first example of a large multi-billion parameter model that was released open source by the big science projects and sponsored by Hugging Face. While this landscape is large and extensive, and it may seem daunting to navigate it, another project comes to the rescue for us. And that project is Ollama. Ollama provides model management and model serving. It enables you to gain access to a large repository of existing large language models. Here, I'm showing the library of the most recent models that have been updated inside of Ollama's library. And you can see that the Mistral models, the Llama models, and Quen from Alibaba are readily available. You no longer need to go out and configure and install and pull and set up each model individually. They're all available now through a centralized and uniform interface. And the best part is Ollama runs on Windows. So if you want to go around and play with this today, you can just go and download Ollama and hit it from your cmd.exe. Here I'm showing the results of running Ollama help to illustrate to you all of the possible, or what's exactly possible within Ollama. You can see that you can pull and push individual model files. This is important because each model can range anywhere from 2 gigabytes to up to 300 or 400 gigabytes for these multi-billion parameter models. When you run Ollama serve, Ollama will start a web server which dynamically manages memory for you, loading and unloading models depending on usage. Here's an example where I'm running Ollama run Lava, a multimodal model based on the Llama backbone. And This looks a lot like Docker because it actually is Docker under the hood. Ollama uses the OCI, Open Container Initiative specification for managing its artifacts. And this 4.1 gigabyte parameter model is pulled from Ollama's model library locally to your machine, and GPU memory is allocated if you're using a GPU. If not, it will run on a CPU. And a chat interface has popped up where you can ask it to tell you a joke about Python. These models are available not just through a command line interface, they're also available via API. And this is how the Open Web UI and Ollama connection is made. So in this example here, I've got a PowerShell open and I'm sending a curl, or I'm sending an invoke web request. So I'm sending an HTTP request with this particular JSON body. You can see that it looks analogous to what you would send to a proprietary vendor such as OpenAI, where you specify a model name, a prompt, as well as a streaming parameter. And the response you get back is analogous to what you would get back from these vendors as well. You get a response, you get a context, as well as you get some metrics about this particular run, such as what tokens were used, how long it took to load the model versus evaluate the model, as well as additional metadata. Great. We've covered the application layer and we've covered the AI layer. And we've seen that Open Web UI can be used to provide an open source, free to use, permissively licensed front end. And likewise, for the AI layer, Ollama can be used to provide your hosted private large language models. Next, we'll move on to the bottom part of the stack, where this actually runs. How do we orchestrate these containers such that they can be scheduled reliably, and they can auto heal, and they can be scaled up or scaled down dynamically? And how do we provide the underlying compute, network, and storage? Since this is an Azure user meetup group, we're obviously going to be using Azure here. But before I dive in here, I wanted to point out that we're going to be using OpenTofu, which is a fork of Terraform. I think that declarative infrastructure is a very important concept. It's sometimes also known as infrastructure as code. And what it allows you to do is specify exactly what you want rather than the steps you would need to take to get there. So this enables, and under the hood, what it'll do is it'll compare the current state of what you want against what's already in production and just apply the incremental difference to get there. I think that infrastructure as code allows you to have reproducible infrastructure that doesn't require you to navigate through a portal, and it allows you to automate and scale up your deployments. The same chart that I'm showing you today is the chart that we deploy across a number of customer installations with minimal modification. Perhaps only the provider is changed depending on what cloud platform that they would like to use. So this is the architecture we're going to set up, and we'll go through it step by step. Your end users will access over HTTPS from the internet into your Azure Kubernetes cluster. At the front of the cluster will be a load balancer service, in this case, routing to Open Web UI. Open Web UI itself will be managed using a stateful set so that in addition to the application instance, we also have a persistent volume for us to persist uploaded documents as well as previous chats. For Open Web UI itself requires a large language model. And in order to keep our deployment private, we'll route it to Ollama, where again, we have a service in order to front our web requests and to route them to another stateful set. The reason we have a stateful set here again is because we don't want to be pulling these model weights repeatedly. And so we'll persist them to disk inside of this 50 gigabyte persistent volume. Setting up OpenTofu for usage with Azure is very simple. All it requires is for you to declare a resource group. In this case, I'm calling it RG, and to give it a location, followed by a Kubernetes cluster using this Azure Resource Manager Kubernetes cluster resource, which I'm calling K8S for now. This inside of here, there's a lot of customization that's possible, but what I wanted to show in particular was this is how you attach this cluster to this resource group so that if you want to, for example, manage quotas and spends, or to just clean up and destroy things from just a single object, that resource group can manage all of that. And I'm also showing here how you can size your cluster, choose instance types. In this case, I'm choosing just a standard D1 V2 for demo purposes. You might want something bigger if you're going to have more than one user on it, as well as a node count, which I'm using 1 for the purposes of my demo. But again, If you would like some redundancy for fault tolerance and load balancing, you may want to scale that up. After declaring your infrastructure, it's as simple as calling tofu.apply or tofu apply, Terraform apply before the license change. And when you do this, Tofu will go and compare your desired state, what you've declared inside, what you've declared as what you want for your infrastructure to look like, against the actual state that currently exists inside of the cloud provider. In this case, I have nothing in my cloud provider. And so the plan here is to add 7 objects in order to spin up this resource group as well as this Kubernetes cluster. And then I can just hit confirm here. And after I confirm, the state of the world goes from nothing into this Azure Kubernetes cluster existing within the Azure cloud. At this point, we now have an empty Kubernetes cluster on Azure Kubernetes service just waiting to be utilized. And so let's start populating it with the objects that we described previously. The first thing I'm going to populate is OLLAMA. And to do that, I'll take this Kubernetes manifest on the left, which specifies a stateful set that uses the latest OLLAMA image, exposes port 11434 under the name HTTP, and requests a 50 gigabyte persistent volume for us to back the model weights with. And then on top of that, I'll specify a service so that Kubernetes DNS registers this OLLAMA name into its DNS registry. And I'll target port 80, the standard port for HTTP traffic, to this specific container port, which I've labeled as 80 and actually maps to container port 11434. Once I apply this manifest, the state of the world now looks like this on the right, where this persistent volume claim is backed by an Azure disk, and the stateful set is utilizing it. And in front of that stateful set, we are advertising a service, OLLAMA, which can now be discovered via kubedns. Next, we stand up our application layer. And in order to do that, it's just the same story over again. We have a stateful set. In this case, it's using OpenWebUI's image. And I've added an environment variable called OLLAMA base URL. This is how I'm able to connect OpenWebUI with the OLLAMA instance we've deployed previously. And because I've already registered this OLLAMA service under this name OLLAMA, Kubernetes DNS is able to route us to this particular instance. We're using port 80 because port 80 is what was specified inside of the service that we've advertised, and the service itself will be responsible for mapping to the container port 11434. The rest of this is similar to before. We have another volume claim template in order to grab a 1 gigabyte volume to store uploaded files and chats. And we have a front-end service here in order for web traffic to ingress into. Okay, now that we have a detailed description of the architecture as well as the manifests, let's see exactly how we can deploy this ourselves and what terminal commands we need to run. To set up the infrastructure, the first step is to clone this repo that I've already provided for everybody, for our attendees. Next, you'll go into the Tofu directory, initialize all of the Tofu dependencies, and hit apply. And that's it. You never have to open the Azure console or the Azure portal. At the end of this step, you'll already have a resource group as well as your network namespaces and your Azure Kubernetes service cluster already deployed. Step 2 is to apply the manifests, which I've provided for us under this K8s directory. So a kubectl apply on this K8s manifests directory will go and iteratively apply every single manifest in there and create your OpenWebUI and OLLAMA instances. And that's it. You're done. Just kidding. If only life was that easy. Fortunately, since we're already utilizing some great services in order to back our deployment, day 2 operations is much simpler than what it was like previously. For logging, you can utilize Kubernetes logs, or you can utilize cloud service provider services. For monitoring, we did not deploy any Grafana or Prometheus to the stack, so you'll rely on your cloud service provider's monitoring services. Patching is as simple as editing the manifests. You can either do that inside of the Git repo, which would be my recommendation, so that you can version and revision control your infrastructure as code. But if you need to make a quick change, you can patch by just editing the live deployment. Scaling is a similar story. I would recommend you go and update the replicas inside of your manifests committed into version control, but a quick fix can be accomplished using kubectl scale. And for disaster recovery, you can take advantage of Kubernetes 1.27, I believe's volume snapshots feature, which which if you're using AKS will be natively integrated with Azure Disk Snapshots and provide thinly provisioned point-in-time restorations. I see a question. How big can the Ollama data directory grow? That's a good question. It depends on the types of models you're pulling. So for example, Llama 3.2 1 billion takes around 1 to 2 gigabytes. Lava, which is a multimodal fine-tune or a multimodal head on top of Llama 3.1, that one's about 5 gigabytes. And if you're dealing with larger models like these 70 billion parameter models, you're looking at anywhere around like 20, 30 gigabytes a model. So it's a combination of the size of the models you wish to run, as well as the number of models you wish to have weights available for at any given point in time. Here I've just provisioned 50 because in my demo, I'm using models that are under 5 gigabytes, and I've only got about 5 or 6 in my demo. Yeah, so do I recommend whether 50 gigabytes is enough? I think 50 gigabytes is a good place to get started. One of the benefits of this volume snapshot feature is you can take a volume snapshot, resize your disk, which I believe in Azure disks, you can do dynamic disk resizing just by editing the size parameter of your persistent volume claim. But even if you cannot, after you take a volume snapshot, you can actually destroy and recreate the PVC with a larger capacity, and then do a point-in-time restoration from that snapshot back to the disk to recover the existing data that was there. And the net result will be you have this higher capacity PVC with the data that was there before. Okay. I mean, this is my last slide. So actually, I mean, thank you for the questions. Keep them coming.
I did also put the repo in chat. I know you listed it at the start, just in case anybody hasn't grabbed it yet. But is there any AI questions or specific questions on this topic itself? We can go as broad or as concise as you guys want. You can also hear, I'm going to turn off the recording that way too, in case anybody